Good morning, guys, and welcome to a Drizzly Gray Wednesday. For today, I'm going to show you how to answer the questions from the quiz prep worksheet, and of course, attached to this link also will be the quiz. I'd like the quiz to be submitted before the end of the day, so, by midnight. I won't check it for grading until tomorrow. If you wanted to share them with me on Google, I can make corrections through Google, but if you send me pictures, I'll just give you the grades, and I'll, again, give you the answer key afterwards. You can compare where you lost points. So for those of you on the chapter test who did that, I am making corrections on the shared document, so you'll see it in red. At least that gives you some advice as to what you could do differently. Okay? Now, to start off reviewing the quiz prep, I will just let you know I did look them over, and I saw that most of them look pretty good. There are some common errors. Some of you are making errors in the statements. Some of you are making errors in just little mathematical issues, whether you're using the p-hat combined or not. But let's go through this and try to take it down. I'm not going to write everything on the board. I'm going to say a lot of the stuff because I don't want this to be a 25-minute video. Okay, so for the first problem, you're given a distribution of men and women, and they tell you that in a randomly selected survey we have and I'll just put my little grid here. I'm going to give you the N, the X, the P hat, the Q hat, and then we'll also do the conditions at the same time, the SRS, the 10%, finding out what NP hat and NQ hat are to be at least 10. So setting up the grid just makes it a little faster. All right, so we surveyed, in our random survey, we had 40 men, and we had 22 who got speeding tickets. We got 50 women, and 24 that got speeding tickets. That makes P hat for men 0.55, Q hat 0.45. For women, P hat's 0.48, Q hat's 0.52. Never, ever, ever stop the process here and say, well, gee, men had a higher proportion than women of speeding tickets, so therefore there's a difference. That's not what we're saying. We take sample data to see if it tells us something about what the population might do. Obviously, there will be sample variation. We want to see if it's significant enough to suggest that there's truly a difference in the population. All right, so our next step is to do the conditions. Now again, it was given as an SRS. So I'll say given for both. 10%, are there at least 400 men who might be able to get a speeding ticket? Naturally, of course, and 500 women? Certainly, that verifies, no problem. We had 22 men, therefore 18 did not have a ticket. We had 24 women, so we have 26 who did not. Now, those are all, of course, more than 10. Our conditions verify. These are also the conditions for the confidence interval. We'd only have to do it one time. There's no reason to do the conditions twice for the same prompt. But when we get to the second prompt, you have to say the conditions have already been verified. We can move forward with our confidence interval. Please make sure that we do that. All right, so my z-score formula is going to be 0.55 minus 0.48 over the square root of, hey, wait, we didn't find our p-hat combined yet. Well, how do we find p-hat combined? I'm going to put it over here for you. P-hat combined is 22 plus 24, the sum of the x's, over 40 plus 50, the sum of the n's. That's 0.5111, making Q-hat combined 0.4889. And that's what's going to go in here, okay? 0.5111 times 0.4889 over 40 plus 0.5111 times 0.4889 over 50. All right? And that gives me a z-score. We boil it down to, what was it? It was small. It was 0.6601. Okay, I'm going to pause there. This is our z-score, not our p-value. We found the z-score for where the difference between the two populations will reside right now. Well, samples, not populations. So 0.6601. I did not yet write my statements, my null and my alternate. So let's do that now. All right, and again, I'm going to have to erase stuff to fit everything in. What's my null? The question was, is there a difference between the two populations? So the null would be there's no difference. Typically, that's what we're going to be looking at. So capital P sub D equals 0. That's my null. The alternate, again, it said, is there a difference? That shouldn't have been an equal, that should have been a colon. Is there a difference? Not, are the men getting caught for speeding more than the women or vice versa? Is there a difference? So what's the alternate? Well, that's that the P sub difference does not equal 0. This one is a two-tailed test. Okay? Well, let's draw the curve so that we know what we're looking at. Okay, here we go. Here's my normal curve, 0 in the center, 0.6601 above it with the symmetric negative 0.6601 below it. We're shading both tails. That's a large area. This is going to be a large p-value. You already know before you even find it, we're not going to reject the null. There's a huge p-value here, all right? It's not far away from the center, which was the null. We're not going to reject this, but let's find the solution, all right? So I'm just going to erase this part of it so I have more room. And I'll say normal CDF from 0.6601 to the infinite bound, and I'll double it right away because there's two tails. The p-value I'm going to get, it's large, 0.5092. That's our p-value. That's more than any alpha is going to be. We fail to reject the null that the difference between the two populations equals 0. Here's what it means in words again. We're not rejecting that the difference between the two populations, proportions who receive speeding tickets, has any difference. There's just no difference. We would not say there's no evidence. We would not say that. We would say that the evidence is not sufficient. The evidence is not significant enough to make us say that there's any statistical difference between the two populations. Okay? That's the interpretation. Don't say there's no evidence. There's some evidence, just wasn't strong evidence. Okay? How do we double check that? Well, you could always use the 2-prop z test function on your calculator. It'll tell you the same information, and it'll verify what you thought. Moving on. The confidence interval is basically the complement of the hypothesis test when it was two tails, and this one was. So number 2 says, make the confidence interval for 95%. Well, okay. Again, for number 2, conditions have already been verified. Say that, write it down somewhere, all right? It proves that you know it's important to do, so please do. And here's what we're going to get for our confidence interval. It's 0.55 minus 0.48 plus or minus 1.96 times the square root of 0.55 times 0.45 over 40 plus what was it, 48 times 0.52 over 50. In the confidence interval, we don't use the p hat, q hat combined. We use the actual values that were p hat and q hat. Anyone notice that it doesn't rattle anymore? I taped down the little things inside the board that were making noise. That's just for me. All right, so here's what we get here. 0.07 plus or minus 1.96 times 0.1057, which gets you 0.07 plus or minus 0.2072, which is negative 0.1372 to positive 0.2772. We are, and I'm going to do the ellipsis, we are 95% confident that the true difference between the population proportions of men and women who get speeding tickets is between negative 0.1372 and 0.2772. 0 is firmly within that interval. It supports our previous conclusion that there's no statistical evidence, or there's insufficient statistical evidence to suggest that there's any difference between them. Again, when 0 is in the interval, it doesn't give you evidence to say there's any difference. The 0 difference is right there inside the interval. Okay, good. Now, moving on to the second. I'm going to shortcut this one because it's very similar to the first, but here are the key differences, okay? In number 3, you were told that the question is, do naturalized immigrants do better on the immigration test than natural-born citizens? This is not a two-tail test. It gave you the information for natural-born first. Natural-born versus immigrants. Okay? I'll just put this up here. I'm going to just say we would have continued it. There were 1,000 natural-born. It said 61% passed the test. That means 39% didn't. And 61% of 1,000 is 610. It also said that of 960 naturalized immigrants, 65% passed the test, so 35% didn't, and 65% of 960 is 624. Okay? And we would keep going with the conditions, which I'm not going to do everything right now. If there's the situation in which the immigrants know more than the natural-born citizens, which I also happen to believe, they're forced to learn a lot of information to pass the citizenship test, they probably know more than we do. My no can be that the proportional difference is 0, but the alternate rather is does not equal 0. If the immigrants know more than the natural-born citizens, the difference between the two proportions will be negative, just like it is in the example. If the natural-borns know less than the immigrants, then we're going to have a higher pass rate on the immigrants. So I'm looking for just a left tail test. If you had said the null was greater than or equal to 0, that's fine. There's no issue there. There's no problem at all. But because specifically we were asked whether the immigrants know more than the natural-born, we could just have said equals. Either which one's fine. It doesn't matter because it's the alternate that matters most here when we talk about the area. All right, so just to shortcut everything, you would have gotten an answer for number 3. Your z-score for the difference was negative 1.8332 if you plug in all the values appropriately. The p-value for one tail, 0.0334. If you got 0.0668, you obviously doubled the p-value and everything else you did was right, except for that. Once again, we had a 1% alpha here, so that's still larger than alpha, so you still wouldn't reject the null, so you still, in this case, wouldn't reject that there's no statistically significant difference between the two groups. Okay? The confidence interval, again, done much the same, would have gotten you an answer negative 0.0961 to positive 0.0161, which does contain 0 within the interval, which again tells you that there's likely no statistically significant difference between the two populations. Okay. The quiz is posted here. Please complete it today. If you have any questions while you're doing it, other than how do I answer this, you can certainly email me. It's fine. Once you finish the quiz, as I hope you're getting used to, I want you to take a picture of the quiz and email it directly to me, htucker@sheltonpublicschools.org. And that's how we're going to move forward, all right? Some of you guys have had some trouble with, how do I get this to you? That's how you're going to get it to me, all right? Take a picture with your phone, upload it to an email, send it directly to me. Any questions, let me know. Otherwise, have a great day.